This is the OpenShift 3 session. Quick round introductions for you. I'm Ashesh Badani, the Vice President General Manager for the OpenShift Platform-as-a-Service business unit. Joe Fernandes, first up on the left. He's Director of Product Management for OpenShift. Matt Hicks, Vice President of Engineering, and Clayton Coleman, Lead Architect. So we're going to spend the next hour walking you through a little bit of the state of the union of where OpenShift is and where we're going from here on out. And then with any luck, we'll have some time for questions. So we're excited. We're excited that so many of you want to come here and listen about the direction for OpenShift for us. So let's get that started. Before I do, two housekeeping items. First one, please don't forget to fill out your eval surveys. And we hope, this is like Uber style, when you go 5 for 5. So, I'll give you 5, you give me 5. And that'll be good. I'm joking. And the second part, which maybe is the most important part, is there's a party tonight for all the folks interested. If you want to go to the OpenShift party, I think you go to the booth and get a pass, and then you can attend. And they're pretty cool. All right, with that, let's get going. So OpenShift 3, lots of customers that we've been fortunate enough to have come and speak at Summit. So take a look at some of these sessions if you haven't already been to some of them. There was a customer panel earlier today. We've got Target speaking, obviously FICO, really happy to have FICO speak, great customer, great partner of ours. Amadeus, right, big launch of Amadeus Cloud Service today. I know Amadeus folks are in here, thank you very much. We're very excited to work with them. Partners like Accenture, Produban, Banco Santander, Cisco. So just a great variety of different sessions, so please check them out. Of course, there's a whole bunch of sessions around product and technology. Go to them as well. Just a few minutes maybe on a little setup on kind of where we are, why we're doing what we're doing. This is a theme we use a lot to drive us in OpenShift. Right? We believe every company is now a software company. Right? The question is, do they realize it yet? And if they don't, right, then they realize they get in trouble with companies that essentially are software companies that disrupt them. Right? And so the question we want to ask ourselves is, which circle do you want to be in? The big one that's disrupting the existing folks, or the little one, right? That's getting disrupted, right? So if you're a credit card company, are you getting disrupted by other credit card companies? Probably not, but more likely by digital payment folks like Apple Pay and Square and other options for that. So just keep that in mind, as you go through and hear us talk. This is what drives us, right? We want to unleash the power for every company essentially to transform themselves to the extent they can to be more innovative and become a software company, or unleash at least all the advantages that gives you. And some data to back that up. I think Jim Whitehurst mentioned this in his keynote yesterday. This is an extensive survey that's done by PwC, PricewaterhouseCoopers, of CEOs. Actually, it's US CEOs as well as global CEOs. I'll use a US sports analogy, playing offense or defense. 36% of US CEOs said they entered or considered entering a different industry at some point over the past 3 years. Means they wanted to play offense, they want to go out and attack another industry because there wasn't enough opportunity or growth for them, right? So they want to go and see where else they can go to help them grow. 61% think it's likely competitors will compete in industries other than their own, right? So they will expect to do some defense because there will be external companies, most likely, companies in the technology business that will come and disrupt them. And about half of CEOs believe, right, so the data point, a significant competitor could come to them from the technology sector, right? So I want to reinforce the earlier point I made, right, that there's a growing acceptance, a realization that every company, if it's not a software company, has to have the capabilities to be innovative, to play offense or defense. OpenShift Online, for the folks new to OpenShift, we've had OpenShift now available for use for about 4 years, over 2.5, that number needs to be updated. Over 2.5 million applications have been created on the platform since launch in 2011. Users and applications have been doubling year on year. Fantastic growth. We're onboarding a few thousand users on every week into OpenShift Online, which is our public cloud, public PaaS offering. And now serving over 1 billion requests a day, so a fair amount of traffic that we're working with. And then obviously a lot of extensions with regard to add-ons and quick starts, and really quick release cycle to get the platform out into the market, right? So every 3 weeks, updating the technology platform. But then OpenShift Enterprise is our private PaaS offering, right? So this is the one that you can run on bare metal, virtualized environment, IaaS, OpenStack, or certified third-party cloud. There's a series of customers, who are references. We're obviously proud of working with all of them. Check them out at openshift.com/customers, and obviously to the sessions that they have earlier. Well, they've had some, today, as well as tomorrow and on Friday. With that, I'm going to switch real quick now to the roundtable discussion, which is really the meat of our presentation today. Also ask the panelists a series of questions. They'll give you some answers. But we'll do a little bit of interactive session around that. And then Clayton's also going to do some demos. So we'll hopefully make it a little bit fun and enjoyable for you. So with that, first question goes to Joe Fernandes. OpenShift Enterprise 3. You want to talk a little bit about what we're doing with regard to that?
Yeah, sure. So we're really excited to announce OpenShift 3 today. It's something that we've been working on for almost 2 years. We didn't set out to do it. We ended up rebuilding every layer of the stack with all the latest innovations from Linux containers to container orchestration, the latest in Linux OS technologies, new middleware services, and new developer and application capabilities. So this is a really, really big release, probably the biggest release we've done since we first launched the product over 4 years ago. And like all Red Hat products, it's fully open source. So this is really a community story. And so our model, OpenShift Enterprise and OpenShift Online, which are our commercial offerings, they actually are derived from OpenShift Origin, which is our upstream community project, GitHub-hosted, Apache v2 licensed. But most of the work that we actually did on OpenShift 3 came upstream from Origin, right? We were very heavily involved in the Docker community, and we used Docker as the new container model, as well as the new packaging format for OpenShift 3. We were also very active in the Kubernetes community. Kubernetes is an open source project that was launched by Google for container orchestration and management. And so a lot of that capabilities now was built by Red Hat engineers along with Google and other vendors, and that serves as the orchestration engine in OpenShift 3. And then Atomic is our new community for doing Linux OS that's optimized for containers. So atomically updated container OS that you know as Relatomic host. So a lot of that technology flowed into OpenShift, as well as other communities we participate in, like middleware communities, other Linux communities, and so forth. So I think Paul Cormier mentioned yesterday, there isn't a single open source community. There's a ton of communities, right? And these are the communities that were critical to what we're trying to deliver in OpenShift 3 and what we're bringing out today in OpenShift Enterprise 3.0.
Thanks, Joe. I'm going to turn this over to Matt now. We've been hearing so much about Docker. I'm sure some of you guys are getting a little sick about this. So one more time, Matt, tell us about Docker.
Sure thing. So I'll actually start, we heard a lot about Docker, you guys probably in the industry. But for us, one of the things that, as I've talked with customers, I'm surprised how few have known that OpenShift, since day one, we built it on Linux container technology. And it wasn't because we could see the future and we know there's going to be all this excitement and popularity. It really, for us, started as a practical decision of we were going to run an online service. We're going to let users host applications on it. We wanted to do that in the public cloud because we thought it was really important for us to know how our product and our service was going to run in a cloud. And when we looked at the smallest VMs that Amazon could provide, they were a lot larger than we needed to run the smallest workloads that we were going to give away for free for users. And that really started us if we needed a different architectural model. The virtualization model by itself was not going to work for us in actually building OpenShift. So we started with that, and the benefits we got from it were the lightweight nature of being able to design around Linux containers and deploy its process spaces instead of full operating systems, gave us a lot of the application agility benefits to it. It also lowered our infrastructure costs. Ashesh mentioned 2.5 plus now, million applications. If we were paying Amazon for 2.5 million VMs, that would be a rough monthly check to cut. And it's a lot better having that flexibility of being able to use every drop of infrastructure you can, but containers gives you that volatility to turn some off, turn containers on and off and tune to your infrastructure. And the last thing is the operational efficiency with it. When you're dealing with that scale, we do not have a massive operational team to manage an environment that's large. That's really a challenge. So we had to be very good at coarse-grained operations. When we do something on a VM or we do something on a host, we like the fact that we can apply updates to thousands or tens of thousands or hundreds of thousands of containers really, really quickly. So that was a lot of the power with it. But I think one of the reasons, we've been asked a lot of, why has this really taken off in the last 12 months or so? And I think with the Docker technology, they did a really neat thing of adding a packaging format to it. So we spent 4 years in the bowels of Linux containers, working with kernel namespaces and Linux control groups in SE Linux. I have learned more about those nuances in my 4 years than I ever thought I would know in my life. And Docker really helped standardize and simplify that, but they also introduced the packaging format. And now on the operational side, when you're looking at infrastructure, and you're dealing with stuff from physical machines that you have on site, to virtualization environments, to private cloud if you're deploying OpenStack, to the various public cloud offerings, you want to have that portability across them. Having the combination of a packaging format where your code can move and a simpler way to standardize how you turn on these capabilities was really, really powerful. Now, with that packaging format and the popularity came a really, really good ecosystem, and that was fantastic for us. We had cartridges, we had our ways to do these, but we were constantly having to find new technology and get in that format. Docker and the packaging format of Docker has drawn practically every technology known to man. And one of the key things we pride ourselves on OpenShift v3 is you can take any Docker container that's out there and you can run it in OpenShift v3. Now that was really key for us because now this ecosystem of practically everything is available to you as a user. That said, that comes with a little bit of challenges here because the first thing is that doesn't mean that everything just magically works, right? There is still this trust element. This one I always can never read. You got the guy with glasses. I think it's 755 repositories that refer to themselves as providing MongoDB. So as a developer, you're like, hey, man, I want MongoDB. Can I spin it up? And you get 755 choices, and this is probably dated from Docker Hub. Now look, like my guess is there are going to be 1 or 2 really good ones, maybe 5 or 10 specialized ones. What are the other 745 doing, right? Maybe not good things there. So you have to have, you get the flexibility, you get a great ecosystem, but you have to introduce trust as well. And so I believe it was in April, Sarah, we introduced our container certification program. So obviously the content from Red Hat, we want you guys to be able to trust it. That's core to our brand. But also, one of the strengths of RHEL has been being able to bring a commercial ecosystem into that, certify their content with RHEL. We've extended that to containers now. So our goal with
Matt,
this is...
I'm just going to jump in real quick and ask you a question. Talk a little bit about what the journey was, right? I mean, we started on Docker a while ago, and is that kind of a one-way street for us?
Yeah, I think a lot of the participation with Docker has helped Docker as well as it's helped us. Because like when we started, one of the first things, I remember one of our first conversations with Docker was around adding RHEL support, obviously, but also SE Linux. Containers comes up, and the first conversation is around security and trust. And as we started working with Docker, providing these enterprise capabilities to the technology, and obviously like we're Red Hat, this is what we do. We contribute what we do back to the communities. I think it's been really helpful for Docker. And then in exchange, it's the symbiotic relationship of we get these options for our users so our platforms become more powerful. This, I think, has been the latest incantation of that is being able to take a commercial ecosystem and bring that to Docker and not just have this be about open source code and software too. So it's been a lot of fun. And so that's our the container certification. You'll see more about that. I know you'll see that down at the booth today. But that was an important area for us is that we want the choice and flexibility to be there. But at the same time, we don't want that choice and flexibility to be crippling. We want to provide options where you guys can simply pick things and know that you can trust them. The last part about this, which was pretty exciting on Monday this week, you might have seen the Open Container project that was launched. So this is something we really, really believe in, is that innovation in open source projects is fantastic, but at the same point, if I'm sitting in your shoes and I'm having to make technology bets, I want to know that those bets are going to stick. They're going to be around for a while. And one of the things around containers was a little bit tricky is a lot of it focused on a single company. And we didn't really have a strong standard there outside of Docker. And so we had worked with Docker. We'd started this a while back now. And as of Monday, we launched the Open Container Project, which is taking the core of Docker, both the runtime and format. It's supported by Docker, Red Hat, Microsoft, Google, Amazon, and practically the world. So Core OS as well. So the AppC Rocket type fragmentation is now gone. That's been a huge effort for us because while we want that stability, we also think it's really key for customers to be able to bet on that and know that there's going to be an industry-wide standard there. So all of those reasons really drove us to, it was an early bet for us, right? It was 2013, I think, when we really decided we thought things were going to go in this direction. It's pretty exciting now to look back and be like, man, that was a good bet. Things there landing. But that's sort of the logic of why it pushed us there, some of the thought. But talk is cheap. So we figured the best way to show this would actually be to put Clayton on the spot, since I was on the spot the other day, and show this in a demo.
So can everybody hear me in the back? Great. So I'm going to do a live demo here. If everybody stays off the wireless for about 30 seconds, maybe the Docker Hub will stay up long enough for me to go grab some data off of it. So as Matt said, it was really important that we're able to pull and run applications that from the Docker Hub, from Docker registries you're already running. And there's a lot of reasons that you'd want to be able to pull down images that people in the organization have built, people in the community have built, and just try it and give it a spin. So I've randomly selected an image that I carefully tested and pulled earlier. And I'm going to download this image, and I'm going to build an application around it. So in OpenShift, if you haven't seen the OpenShift UI last night, or you just caught a glimpse of it in Matt's demo last night, the OpenShift console in V3 is built on top of Kubernetes and Docker and all these great concepts. Specifically, I'm on the command line, and I'm just going to go and I'm going to create an application. It's going to tell it to pull all the information it needs to build this very simple application from the Docker Hub. So it's connecting out to the Docker Hub right now, and if the wireless works, then that's great. And then you can see here, because I already had the image on the machine, startup was practically instant. So this is one of the things we think is the most important about Docker, is this idea of these immutable images. You pull them down to your machine. If you already have the image there, nothing's changed. It comes up instantly. So we delivered a little bit of configuration in here. And if I want to actually see this application, I'm kind of running in a way that I've got access to the internal cluster. But we set up DNS for you that makes it easy to access the application. And if everything goes right, my DNS server responds, which it won't. Of course, Chrome decides to make things difficult.
This is the time when you blame the wireless.
Yep. So the DNS server fiddliness on my laptop, Macs suck, all that stuff. So I'm going to go back into the console, and we've created this application. It's a really straightforward application. I just pulled an image that someone had already built off of the Docker Hub. The application is actually running on my cluster, and I bet you the first thing people thought of was, haven't you spent the last year telling us that randomly pulling images off of Docker Hub is a bad thing because you just gave someone root access to your machine? And in most cases, that's true. One of the things that was really important for us with OpenShift was carrying forward the patterns that we had already put in place for administrators for V2. So I'm going to jump into my container real quick. And OpenShift, like OpenShift V3, like OpenShift V2 before it, has a way for you to get inside your containers, as you may be familiar with from Docker. And I'm just going to run a bash session inside this container. And once I get inside that container, I'll be able to, Okay, so I'm inside the container, and I talked about security. Normally this container is just going to try to run as root because that's how everybody starts things up. OpenShift actually applies a security policy to everything that runs by default that locks all this down, puts you in a high UID. It actually even goes so far as to ensure that you have a proper SE Linux label on this. So OpenShift is set in force 1 by default. I know some of you guys walking around with those shirts. That's what we believe, is that containers are important, but we want to build in the protection so that you can run your applications, your customers' applications, and even things from the internet, and have some confidence that the stuff you're running is secure out of the box by default. So I'll hand that back off to you guys.
Cool. Thanks, Clayton. So was a live demo, you weren't faking it, right?
I will pretend to do some even more impressive stuff
Excellent.
On my video.
So talking about demos, right? How many people caught the demo yesterday? The 1,000 containers up and running. Wasn't that pretty cool? Yeah. So great stuff there. Clayton obviously not going to go to that scale today, but there's just an example of the work we've been doing around scalability. Okay. So I'm going to come back to you, Joe, a little bit, right? So in as much as we like to think of ourselves as pure technologists, it's a little bit of a fashion industry. So is Kubernetes now sort of the new skinny jeans?
Thanks for throwing that curveball at me. So yeah, what I was expecting to answer was, what we know about applications from running OpenShift is that they don't just run in a single container, right? To run a real application, real enterprise applications, they're going to span multiple containers. So whether that's a clustered Node.js service, a clustered Tomcat or JBoss service, that's multiple containers making up that service. And that service then needs to connect to other services like cache services, database services, right? So something needs to orchestrate all of these containers and manage all of them. And you need more than Docker to do that, right? And when we started looking and tackling this problem, one of the companies that we talked to was actually Google. And Google has contributed a ton to containerization. They told us about a new project called Kubernetes, which some of you have heard about now through the sessions you've been to. And Kubernetes was an open source project started about a year ago that we decided to join in on and really drive some of these capabilities for OpenShift 3. And to simplify it, I think about 3 key capabilities that Kubernetes provides. The first is that orchestration of multi-container services, right? Wiring these services together, wiring them to other services so that you actually have a topology that works, right? An application that makes sense. Then it handles the scheduling of the containers across a set of hosts. You don't want all the containers for a service to land on the same VM or the same server, because if it goes down, then you're going to lose that service, right? So deciding how you want to schedule these out across a set of nodes, a set of hosts, is another important consideration and something that Kubernetes handles for us. And then third is managing the lifecycle of those containers, right? So when you define a service in Kubernetes, you define how many containers a service should have, what their state should be. And Clayton's going to show this in just a second. And then Kubernetes has a declarative model to maintain that state, right? So if a container ever fails, if the server doesn't meet the declaration, it'll automatically restart the container, restart it on another node if it needs to, and basically keeps those services up and running. So these are the 3 key functions that we saw that we really wanted to drive into the product. Kubernetes also has a very cool model, a very powerful model for container networking and container storage, right? So in the Kubernetes model, containers actually run in these abstracted containers called pods. And each pod has its own IP address. So now your containers are directly addressable, and it makes it a lot easier to run software compared to how things used to run in our V2 platform where everything was running behind a vHosted type setup. And then what we ship out of the box is a networking solution that then spans all these containers. We provide a router and an Open vSwitch-based networking solution that handles that for you out of the box. We're also working with some of our networking partners to integrate their SDN solutions into OpenShift. And then Kubernetes also provides a model for mounting storage volumes to your containers. And this is really important for running stateful services, right? I know we're in 2015, but not every application is stateless, and not every service that you want to run in containers is going to be stateless, right? So you may want to run a database service. You may want to run a messaging queue. You may want to run an application that still stores stuff off to disk. You don't want to lose that data when your containers restart. So by mounting storage to your pods, Kubernetes provides a way for the storage administrator to set up storage volumes, and then application owners can then mount those storage volumes to their containers. And then even if your container goes down, Kubernetes is smart enough to reattach storage to the new container wherever it may come up, even if it comes up on a different host, right? So this was very powerful stuff, and now allows us to really move beyond just the stateless 12-factor apps to run stateful applications, stateful services, and really try to drive everything to run in containers. Because at the end of the day, a container is nothing more than a process on Linux, right? So anything that runs on Linux should run in a Linux container. But you need to have things like storage and networking and all these constructs set up to make that real. That's what we're working on. And this is part of our belief, right? We're trying to drive and adopt best-of-breed solutions wherever we see them, right? We don't want to have OpenShift-specific solutions if there's a better solution out there. And in Kubernetes, we saw a lot of great technology, but also a great partner in Google and other vendors who really brought a lot of expertise to the table. So when Google launched Kubernetes, they talked about how they're running over 2 billion containers every single week. So every processing, all the processing that backs Google services, whether it's Gmail or AdWords or Google Docs or what have you, all that processing on the back end happens on bare metal servers inside of containers. And I know Google is doing a couple of sessions here at the conference, so I encourage you to check those out because it's a really great story. They also launched something called the Google Container Engine. The Google Container Engine, much like OpenShift 3, is powered by Kubernetes, right? So, and there's actually other smaller vendors that are also building their own solutions that are powered by this technology. So that really yields a lot of great innovation and a lot of rapid innovation. And it's been amazing to see the progress in this project over the past year. And it's basically now what we're bringing in OpenShift 3. So enough talky talk. I'm going to turn things back to Clayton. He can actually show you a little bit about how this stuff works in action.
Great. So I'm going to, so before I just pull down an image and ran it, I'm actually going to put together a semi-real app. And this won't have stateful storage connected to it. I didn't want to risk the wrath of the demo gods in today's example. But I want to highlight OpenShift is about building patterns out, allowing organizations to share those patterns and work with them. So in the OpenShift console, one of the concepts that we've built is on top of Kubernetes and the OpenShift concepts, building out templates that allow application administrators to pre-can things and deliver them to their organizations, allows development teams to hand things off to ops. So I'm going to create a Node.js MongoDB example. And unlike the previous example where I just pulled down some random image from the internet, in this case, I'm actually using the Node.js image that ships as part of the OpenShift enterprise distribution. These are supported images that are built on top of RHEL. They come with supported versions of Node.js. If you hit an issue in Node.js, you can talk to your account rep, and he'll fix the issue, find someone upstream. In some cases, we have people in these upstream communities. Like, this is some of the ability of Red Hat to move the upstream communities to where our customers need to be. And there's a lot of things that use. It's not just enough to build a container. You need to think about things like, will that container run if I'm not running as root? Will it be able to store all of the data in volumes? And so we try and put patterns in place and document how we do this, and they come out of the box in the templates we create. So this is a Node.js MongoDB example. It's combining a Node.js image, a MongoDB instance, and I'm pulling the source code from GitHub. This is, if you go by the booth, you'll see a lot of the same demo being run. And I didn't have to specify anything. This will set up all the security arrangements and all that. So when I click that, we declared what we wanted. Kubernetes is under the covers going and satisfying this, bringing all these things up. And because this is a fairly small app, and I'm just running this on the local VM I have on my machine, everything starts up pretty quickly. You'll see those images are already pre-pulled. Again, they started almost instantly. A build starts running. We have a lot of great capabilities. Our builds run on the infrastructure. So when you're an application administrator and you're running 10,000 applications, and a Heartbleed vulnerability comes out, one of the downsides of image immutability is you probably want to go rebuild those images. So with OpenShift, we actually took a very conscious decision to build a pattern that makes it easy to build and deploy applications on top of OpenShift, including building those images and rolling those updates out. So an administrator in one spot clicks a button to start the base build, and a whole chain of builds run on the infrastructure, roll those applications out. So the application is completed. I'm going to hope that DNS is still working. And this is, this example, if you've used OpenShift v2, you'll see help pages a lot like this. This is the sample app that's giving you a little bit of an introduction to what the OpenShift cartridge does and what some of the things we've set up for you are. Down here, it's actually connecting to MongoDB in the example. We got a cute little counter down here that stores it in Mongo. The Mongo database is running on OpenShift. And this is a standard development setup kind of database. But I'll talk a little bit more in the third section just to pique your interest about what sorts of things you can do with access to persistent storage. So I am going to shell into my database. And I'm connecting into the pod. I'm just connecting into the running Docker container. And the command I run was the Mongo shell. So you can see in here that if I look at the database, you can see the data that we were writing in from the web console. So again, these are tools that we're providing to make it easier for developers to get familiar with PaaS. There may be some organizations where you don't want to allow people to get into the containers. And we have a way of, I'll talk about that a little bit later. You can take that ability away from users if you want a real pre-canned experience. Or if you're trying to move big, complex legacy applications off, sometimes you just got to go in and hammer it with hammer it to get it working. So we're built on top of Kubernetes. All of these components are running. The Node.js front end is talking to the back end through something that Kubernetes calls services. Services are like the internal redundant clustering and load balancing. Each of those has a DNS name. There's a whole bunch of awesome features. I could talk for about 30 days about that. The only thing I really want to highlight right now, because we have such limited time, is when Matt was up on stage the other night, you saw the demo of scaling up to 1,000 containers. 1,026 across a number of hosts. I'm just on my laptop here, but the pattern is really in under a second. these containers were scheduled and associated locally. The containers then start running again. I didn't have to pull anything else. This is the benefit of an immutable infrastructure. Again, like all of these things are exactly what I want. They've already been pre-delivered. You can do optimizations to deliver these as fast as possible with BitTorrent or whatever. But the end goal is that there's no difference from a development machine to running at these very large scales. So I will show a little bit more in the third section, but I'm going to cut back over now just to keep something for the last one.
OK, great. Thanks, Clayton. So before we go to the next section, Joe, you talked a little bit about Kubernetes, right? Big investment from Red Hat, and definitely the OpenShift team, right? From a contribution perspective amongst the top contributors. In fact, Clayton was one of the top contributors into the Kubernetes community. We also started extending out into lots of different areas, right? Because there were problems, in terms of areas that, for example, we work closely with Amadeus on. We have requirements that we work together on, address them around storage, networking, and so on. Clayton, you want to talk a little bit kind of about how we've helped drive that change upstream, start trying to expand out, if you will, the mission?
Sure. So when we originally sat down and started talking with Google about a year ago, the Google has had a great bunch of patterns they believed would work at scale. It was actually great. Every day we were sitting there and chatting with them on IRC and in the issues on GitHub when we were collaborating. Every single pattern that they were showing us, we felt like we could contribute something because Google runs at massive scale. Google runs data centers with tens of thousands of machines, and they build their software custom to the things they need. But that's not necessarily how the rest of us work, right? We take software that other people are providing for us, and we need to get it running as well. So we were able to offer a lot of valuable advice on how to bring people on, how to bring things like Rails and PHP and all these to Google-style infrastructure. And at the same time, we identified pretty early on that we knew that there were things that we wanted to build a really solid foundation in Kubernetes as a runtime environment, but we still, in OpenShift, knew that we needed to accomplish these things. So we worked really closely with the Google guys to sketch out what would be in Kubernetes, but what we wanted to build as an ecosystem around Kubernetes.
Yeah, and this has really been about not just making OpenShift enterprise ready, but all of these technologies, right? Your enterprise data center doesn't necessarily look like Google's data center. You don't have the same networking, the same storage, the same constructs, right? So we want to be the company that's bringing these technologies like Kubernetes, like Docker, to the enterprise securely, integrated with your existing infrastructure, integrated for your application services, right? And that's why, as a result, we've become, at Red Hat, the #2 contributor overall to the Docker project, second only to Docker Inc., the #2 contributor overall to the Kubernetes project, second only to Google, right? So we're not just adopting these technologies, we're actively building them and building them in a way that will work for our enterprise customers like yourselves. And that's why folks like Clayton, Clayton's the #3 contributor to the entire Kubernetes project over the past year. And we have a lot of great engineers contributing to that project across all of our teams, the OpenShift team, the RHEL team, and other teams within Red Hat.
Great, super. Thank you, Clayton and Joe, for that. So this is an important note, right? We're contributing actively upstream, making sure that everything we do isn't bespoke for one specific organization or customer, make sure that's available to the community. So Joe, clearly there's work we've done over and above and beyond just basic, if you will, Docker, image packaging, API, and the Kubernetes project. How else is OpenShift adding value?
Right, so one of the things we like to talk about is you need more than containers and orchestration to build an application platform, right? And really, this is what OpenShift is all about. It's about building a platform that works for developers and works for the operations teams that support and enable those developers and manage the applications, right? So developers need things like self-service deployment capabilities, like what you saw Clayton show today. They need support for different programming languages, different frameworks, but they need to have those, make sure that those get supported as new updates come out, as patches become available. The ops guys care a lot about security vulnerabilities and keeping those runtimes up to date. They want to automate everything, right? Everything from your build processes to your deployment processes to scaling, right? And they want to be able to collaborate with other developers on their application projects and get their job done, right? But you need to provide this on a platform that operations folks, that the business can trust, right? Something that's secure, that's standards-based, that's enterprise grade, and like everything at Red Hat, built on open source technologies, right? Because you want to ensure that these will be able to run your web scale applications. And this is really what OpenShift is about. It's about bringing these technologies together on a platform that makes sense and that works for both sides of the house and for the DevOps folks who are bringing these sides together. So Clayton already showed self-service from the web console. He also showed our CLI interface, our command line interface. We also have an Eclipse IDE plugin that we worked on with the JBoss Developer Studio team. And then everything is calling into RESTful APIs. So we have partners that you'll see in the partner pavilion that are building their own front-end interfaces to OpenShift. And then you can automate those calls, right? So if you want to do an automated deployment pipeline, you can automate those deployments by talking to OpenShift from your CI systems, your build systems, and so forth. You know, Matt talked about the ecosystem, right? This was very big, right? If a developer doesn't have the software they need to build their applications, they can't use your platform, right? So by tying into the Docker ecosystem, we felt we were tying into the largest packaged software ecosystem that exists today, right? Hundreds of thousands of container images available on the Docker Hub. And then on top of that, we can work with our product teams to deliver supported, stable, certified services from things like our JBoss middleware portfolio, from our RHEL portfolio, and from other areas of Red Hat. But we can also work with ISV partners to help them certify their own solutions. So you can get trusted and supported solutions from Red Hat or our ISV partners. You can get stuff from the community. And then because all this is built on Docker images, Docker files, you can create your own custom solutions. Or you can start with one of our images and then customize it to your own needs based on how you want to configure JBoss or Tomcat or your Ruby stack or what have you. We also built build automation. So you saw a little bit of that. Clayton will get into more of it in just a second. But when you're moving to an immutable infrastructure model, everything is running based on images, right? So your instances are running based on the last set of images that was used to deploy those instances. So if you want to make a code change or configuration change or patch the runtimes, you need to be able to rebuild those images because you want to always know the state of what's running, right? So OpenShift has built-in build and deployment automation. We can do standard Docker builds automated across all of the OpenShift users. And we can do something called source to image, right? Source to image allows us to take source code from a repository like GitHub and then basically push that to the platform, match that up with an image. So in this case, if you're pushing Java source code, matching it up with something like a JBoss EAP image, then automatically pull remaining dependencies, in this case from Maven, and then build a new layered image that's got your application, your configuration, plus the base image ready for deployment. And then deploy that out to your instances based on the deployment pattern that you choose. You may choose to do a rolling deployment, a canary deployment. You may define your own deployment patterns based on whether it's a dev environment or a production environment and so forth. And then it doesn't end there, right? Because you're always going to have to update those images. You may want to push new code. You may want to modify the configuration. You may get a new patch from Red Hat or one of your ISV partners. So the ability to constantly rebuild and redeploy those images is also important. So all of this is automated, and you can even completely remove humans out of it. We have things like webhooks APIs for Git. We have CI integration, where this can just be a completely automated process from just a developer pushes code, and the next thing that happens is it goes through the pipeline and ends up deployed on the OpenShift platform. So that's really what we're trying to, the value of OpenShift is giving you a complete and fully integrated solution, right? Not just Docker, not just Kubernetes, not just a bunch of container images and so forth, but something that's completely built and ready so that you can actually step up to it as an administrator, install it, configure it the way you need to on your infrastructure, and then as a user, go in and basically access and create projects and deploy the applications that you want to run on the platform. So again, I'll kick it over to Clayton for our final demo where he'll show you some of the OpenShift specific features that we've built around this technology.
Thanks, Joe. So we have a few minutes left. I'll try to hit as many things as we can, but we built these things on top of the infrastructure, and we actually use the infrastructure. So in a lot of cases, the things that we were pushing in Kubernetes were exercising Kubernetes. We run builds on the cluster. We actually run your deployment in the cluster, which means when you want to set up a custom deployment, you just add it to your Docker image and you invoke that. You don't have to come up with different mechanisms for doing all these tools because we're actually giving you a place to run code and execute. So I'm going to start a build. The build will take about 20 seconds. I'm going to go back to the overview page so you can actually see a rolling deployment. I've got 5 instances of this, and when the build completes, it's pushing that image back to the integrated OpenShift Docker registry. That Docker registry is the V2 open source registry with some hooks to integrate it back into OpenShift so that we can get notifications about when things change. So when the build completes, it pushes the image. OpenShift has that integration, and it can detect that the new image is available. And one of the fundamental models we had was we wanted to build a deployment pattern that would work regardless of what sort of problems you hit. So the build completed, we set up a new configuration for it that's using that new image. The build is going to get scheduled and probably will start at some time. It'll eventually complete. That's our new model, is everything is eventually consistent. So in this case, if it lost connectivity to the node, this will wait, and the deployment process will wait until something is connected. It will actually not roll forward with a deployment, as Joe alluded to, until a canary has passed. And so now that the container is up, you'll see the ready count's gone to true, and in a few seconds, the remaining pods will be scaled down, and we'll continue that rolling deployment from the old deployment version to the new deployment version. And in the event that something went wrong and it never actually became ready, we would stop and roll back. And I think that the demo gods have frowned on me at this point in time. The deployment is probably still running. Oh, there you go. So after a few seconds, whatever it was that was causing it, didn't matter. The infrastructure was able to survive that, and it just said, I'll come back and try again later. So we're just moving through the process of rotating these containers. As they get rotated, they get taken out of rotation. So I'm not showing the OpenShift router today, but the OpenShift router is an extensible way of hooking in any kind of front proxy or load balancer. We, out of the box, have HA proxy and an F5 integration, or the F5 integration is coming soon, but we'll have examples for Nginx and Apache, so you can do this sort of custom logic. All of that endpoint integration is built off the same platform as OpenShift. So we haven't actually required any of the infrastructure for your load balancer to know about pods and deployments and all that. They just see a list of the IP addresses that they need to expose.
And I think, too, one of the coolest things about this that I always like, and we've been asked about it a lot this week, is this is applicable for development. If I change my code and config, push, go do a rolling deployment, as it is for an operations team that says, I just found shell shock, patch the base image, publish it, and do the rolling deployment. All uses the same mechanics there. So it's really powerful there from either side of the
And the other thing is, if you have infrastructure that already does your image builds, we can just take that as input and run those images on the platform,
You
right?
can just push your images to OpenShift, and you can set up security policies around who can push to OpenShift. When you go and create a project, you can actually push images to the project without having to do anything in Docker, and it's fully secured by virtue of you being a member of this project. So just to demonstrate, I don't know if you guys caught this earlier when I logged back in when I reopened the window, but OpenShift has added authentication, all the same things we had in V2, a little bit more flexible and more powerful now. We have an OAuth integration that sits on top of Kubernetes. We have access control, authorization around Kubernetes roles, memberships, a lot more flexible policy engine there. And it is extensible in a way that it was not before, where you can come in as a user and get access. As an administrator, you can allow certain people to do certain things in a much more fine-grained way than previously. We also have quotas and limits, so this is an important part about how do you divvy up the limited resources in your data center. If you want to set very aggressive limits, you can. I've got the simplest possible quota here. So this is pods, number of pods I can run. Essentially, you can set quotas on anything, and some of those limits need to be added via code, but they're all basically just simple counts. So as an administrator, it's very easy for us to go in and add new types of things to be tracked. So in this case, I'm actually using 6 pods. If I scale up to 20 replicas, what'll happen is the system will say, well, we wanted 20, but we can only have 11 because I already had one for the MongoDB container. And it's just going to sit there. And the system says, well, I can't do anything because if you go and look at what the system is telling us, we're recording that we can't do anything because you're actually hit your quota. The system doesn't think this is abnormal. This is just the situation is we're trying to scale up, and when we eventually get past it, we can. If I cut back down to 11, the system will say, OK, you're back to the normal state. And again, so like OpenShift is about setting these policies as an administrator and giving you the tools that you can control what's going on in the infrastructure.
Yeah, so you set those policies as an administrator and then just make the platform available to your users. So instead of pod count, if you want to limit them based on memory or CPU or other parameters, that's all available. And then basically, the users get assigned to the projects that already have these quotas predefined, right? So you can allow users to create their own projects, or you can lock them down and basically say, these are the projects that I've given you access to, and you can create your services within these existing projects, right? So it's a whole roles-based access control mechanism built around the projects and then the quota that's assigned to those projects. It's really powerful.
And we have the integrations in Kubernetes, but like for now, these are things that we knew that enterprise customers needed. And just as a way of helping Kubernetes get to 1.0, we said we're not going to blow up your project by dropping just as much features in as we're adding into Kubernetes 1.0, we have the OpenShift Origin project, which is where we build that distribution of Kubernetes. So we have time for one more demo?
Yeah, sure.
So last summit, we were showing Gearbd and Atomic and Docker at the time. We showed a clustered MongoDB replica set. So it was a real focus for us to have the tools that allowed us to run any kind of software on the infrastructure. And so part of the work that we've done over the last year has been working in Kubernetes and in OpenShift to make some of these patterns easily available. And there's still lots of work to do. Everybody who's an administrator here knows that setting up some of these replicated cluster things is not easy. But I think a fundamental difference now is that we have infrastructure in place that, as an administrator, I can set up very simple deployments that configure themselves automatically. So I have a clustered MongoDB running. It took about 10 seconds to run. If I were able to jump into the containers on here, you can.
So Clayton, much as I don't want to be rude, we've got 10 minutes to go.
Sure.
So we're gonna
it's either demo or roadmap.
This is the last one I was just going to show.
All right, go.
And you cursed it, Ashesh. Man, really don't want to pay attention today.
Okay.
So, but yeah, so this was just setting up a cluster DB where all of these things are possible now, whereas in OpenShift 2, we were in the old model of PaaS, which says you can only run 12-factor apps, and you can only do these very limited things.
Okay, great. Thanks, Clayton. Sorry to cut you off there. We've got about 10 minutes left, so Q&A will probably not happen unless it happens in the evening over beers, which I'm sure we're happy to do. So real quick, right, recap. We pulled random images from Docker Hub, which may or may not be a great idea. That's up to you. But we did it. Right? We did some orchestration, showing you Kubernetes. Did some value add with OpenShift and policy. Kind of showed you that, right? You got a good sense of that. And I blew up one of Clayton's demos. So there's a lot of work that happened, right? 18 months or so ago, when we went off and as a group decided, I don't know if I want to call them bets, but basically say, look, here's how we're going to improve our roadmap. For the future, we asked ourselves, are we crazy, right? In retrospect, everyone comes back and says, yeah, of course you should have done Docker, of course Kubernetes, right? But at that time, right, there was a big leap of faith, we had. So, Matt, you want to talk a little bit about kind of, where do we go from here?
Yeah, sure thing. So, when we talk about the what's next type areas, as excited as we are about containers, because we've been living them for 4 years, like really, really living them, everything in your environment won't be containers tomorrow. So when we looked at the operational side, we wanted to have an operational management story that would span beyond containers. This is actually a screenshot of a demo that'll give you a sample of some of the container management functionality that we're building into CloudForms itself. Our goal with that is with OpenShift, then, you're going to get the container management capabilities, but it's built on a platform that can do containers. It can correlate that to your VMs, to your physical infrastructure, to your network, to your storage, because that's going to be your reality managing that. If you jump forward one slide, our other brethren in terms of crazy, wild, fast-moving, innovative open source projects is OpenStack, and it's something we hear all the time. We're really, really excited about this because whereas today, you can certainly run OpenStack and OpenShift together, right? It works really well, but there is a ton of deeper integration we can do, whether it's in Neutron, we're both based on an OVS type solution, OpenFlow, being able to drive closer networking integration as well as storage. We think the coupling of further integration of these platforms, you're going to see a lot of that from us. This is why we drive and contribute a ton to both these projects.
Yeah, one of the things we love about OpenShift is it spans so many different technology areas and really pulls all of Red Hat together, right? And so another example of that is the middleware portfolio, right? So we're shipping with supported images for JBoss EAP, which is our commercial app server, and JBoss Web Server, which is our commercial Tomcat distro, as well as a supported messaging service based on AMQ, which is our ActiveMQ-based messaging service. But we're working with the integration team. Before the end of this year, we'll have a JBoss Fuse service, so you can get full camel integration capabilities, lightweight ESB capabilities on the platform. And as you already saw last night, you saw the preview of work that's underway to bring all of the Red Hat mobile platform onto OpenShift. So we're working with the Feed Henry team to take all those mobile services and fully integrate them, fully support them, so that if you want to build enterprise mobile applications, you can build them in conjunction with all the other applications and services that you're building and running on OpenShift. And then we're even moving into the BPM area to do things like decision services based on our rules engine, BRMS, which is our rules-based rules management system product. And then we have a whole BPM suite for business process management, right? So we want to offer all of these services, not just as products that run standalone, but as products that run as cloud services available on OpenShift. And then you can pick and choose the ones that make the most sense for you.
Joel, let me just jump in. We've also been doing all these partner workshops, right, to offer additional.
Yeah, and then I'd be neglectful if I didn't say, a big shout out to our ISV partners. Yep. If you go down to the booth, there's an area called OpenShift Partner Row, and I encourage you to talk to all of our partners and talk to them about all the great things they're doing to integrate their software onto OpenShift 3, because that's a big part of the story as well. We're also bringing OpenShift 3 platform to our public cloud services. So we really have two distinct services. One is the OpenShift Online service. The other is called OpenShift Dedicated. So we announced today that we're actually opening up a tech preview of the new v3-based OpenShift Dedicated service. This is a public cloud service that's managed by Red Hat, where you basically run your applications on dedicated infrastructure. So all the VMs that we spin up in the cloud are running just your containers, right? So for folks who are interested in that model versus deploying OpenShift Enterprise for yourself, you can be part of that program, and we're planning to have that fully supported by the end of this year. We're also in the process of migrating the full online platform and the hundreds of thousands of apps that are running there onto the v3 platform as well. We expect that will be cycled through that by the first part of the next calendar year and so forth. So basically, we're taking v3 to every platform that we ship and support here at Red Hat. And then OpenShift Enterprise 3.0 is what came out today, but we already are in the process of working on the next set of point releases. So there'll be a 3.1 release out before the end of this year, and then a 3.2 release out in the first part of next year, right? And we're working on features like really robust metric-driven auto-scaling, right? So where you can feed in your own metrics from your own monitoring tools or from metrics that you pull from the platform, set your thresholds, and have that drive the scale up and scale down of the services. We're working on a model for storing and registering external services, right? So we already know that applications that run on OpenShift are going to need to connect to other services that are in your data center. We can do that today. We want to make that even easier and be able to register those so that you can just call them by name and so forth. We're working on updates to our image services that we get from the software collections team, so new versions of Python, Ruby, PHP, Node.js, and so forth that are coming down the pike, in addition to all the middleware stuff that I talked about earlier. And then enhancements around user experience, logging and metrics, and then work on the infrastructure areas like storage, more storage plugins, networking enhancements, and so forth. So a lot of great stuff. This is really just the beginning for us, even though we've been on this journey for a while. This is really just the beginning. We have a platform that just has a lot of potential for us to build all great capabilities. And so we'd love to hear from you in terms of what would you like to see, what did you not see in today's session that you'd like to learn more about.
Wait.
And get
Grant's got a plug. Grant, you want to plug the T-shirts, hoodies? What do you want to plug?
Yes, stop by the booth. Yeah, stop by the booth, the OpenShift booth. You can get.
Can you model the shirt? Oh my gosh!
You can get your brand new OpenShift 3.
And then behind it says "Can't contain this."